Imagine if someone told you there was a monster in your closet that comes out only once every 100,000 years to eat your house, and you couldn't stop it until now. Now, imagine that this has already happened 3 times in the past, and scientists know exactly where it will strike next. Well, there actually is such a monster, but instead of your closet, it lives beneath the surface of our planet. And instead of eating your house, it devours entire continents. It is a supervolcano, an underground cauldron that every so often blows its lid and unleashes fiery doom upon the world. 3 of these supervolcanoes have already erupted in the past, leaving behind craters so vast they can be seen from space. And although there is nothing we can do to stop them, there may be something we can do to lessen their destructive power. Here are the biggest volcanic eruptions in history, and what they can tell us about the one that's coming tomorrow. Volcanoes happen when magma from deep inside the earth escapes through weak spots in the crust. This magma, which is molten rock, is less dense than the solid rock surrounding it, so it rises up towards the surface. As it does, pressure from the surrounding crust squeezes water and other volatiles out of the magma. The resulting steam and gas expand, increasing the pressure until finally the magma breaks through the crust and erupts. If the magma makes it all the way to the surface without breaking apart, we call the result a lava lake. But if the magma breaks apart along the way, we get a lava flow. The type of eruption depends on the amount of dissolved gases in the magma, known as its volatile content. The higher the volatile content, the more explosive the eruption tends to be. But even among volcanoes, there are different levels of explosiveness. Most are pretty small potatoes, literally. Small volcanoes like Mount St. Noggins in Oregon erupt frequently, but do not pose much of a threat to human life. Larger ones like Mount Vesuvius in Italy are much rarer, but can cause massive devastation, as they did to the Roman city of Pompeii in 79 AD. Even larger still are supervolcanoes, which erupt once every few 100,000 years and can kill millions, if not tens of millions of people. We know of 3 such supervolcanoes in Earth's history, all of which are located in the so-called Ring of Fire that surrounds the Pacific Ocean. The first was the Oruanui eruption in New Zealand, about 26.5 million years ago. It had a volcanic explosivity index, or VEI, of 8, which means it blew up more than 1,000 cubic kilometers of ash and pumice into the air, nearly as much as the largest volcano ever, Mount Mazama, in what is now Crater Lake, Oregon. Eruptions with a VEI of 8 are so rare that scientists aren't even sure if they've happened since humans have been around. The Oruanui eruption left a caldera 45 kilometers wide, now home to a single lake named after it. The second was the La Garita caldera in Colorado, USA, about 27.8 million years ago. This eruption had a VEI of 8 and was at the time the largest known eruption in Earth's history. Since then, however, even larger eruptions have been discovered, including the aforementioned Mount Mazama in Oregon, which had a VEI of 7, and the Toba super-eruption in Indonesia, which had a VEI of 8. The Toba eruption is probably the most famous of these ancient supervolcanoes. It happened roughly 74,000 years ago, which is recent enough that humans were definitely around to witness it. Some researchers believe that the fine ash from the eruption created a so-called impact winter that caused a mass extinction event, wiping out between 75% and 90% of all plant and animal species, including modern humans, Homo sapiens, Neanderthals, and many others. Fortunately, however, other researchers argue that the isotope record shows that the eruption did not have an immediate effect on the climate or the biosphere. And genetic studies of modern humans indicate that there was no population bottleneck around the time of the Toba event. So while it certainly would have been impressive to witness, it didn't wipe out humanity, allowing us to live our little lives and watch YouTube videos on our phones. For that, we should thank whatever deity or deities are in charge of making sure that humans don't end their own existence too early. But now let's talk about the future. Unfortunately for us, we don't have a lot of data on how supervolcanoes work. In part, this is because they don't happen very often. We can study the frequency of smaller eruptions, But the bigger ones are so rare that we have no choice but to rely on computer models. This is the main reason why there is so much disagreement over whether or not the Taupo eruption actually caused an impact winter. There are also good reasons to think it didn't. One problem with studying the past is that by definition, it's gone. You can't go back in time and collect data. You can only work with what's available. With supervolcanoes, this means mostly geological evidence left behind in the ash layers of ancient sediments. For the Toba eruption, this includes the fact that the volume of ash is much smaller than expected, suggesting that much of the ash fell into the sea where it has since been lost to erosion. Other evidence includes chemical analysis of ice cores from both poles. These show an unusual depletion of sulfate in the ice layer corresponding to the age of the eruption. Sulfate is what forms when sulfur dioxide gas reacts with water vapor in the atmosphere. Sulfur dioxide is released during volcanic eruptions, and some of it eventually makes its way to the poles where it falls as snow. Less snow means less sulfate, and yet there is no significant decrease in sulfate in the ice layer corresponding to the age of the Toba eruption, meaning it likely did not release much sulfur dioxide into the atmosphere. Still, there are signs that the Toba eruption did have some effect on the climate. Pollen records from Australia show a sudden and dramatic decline in diversity, coinciding with the age of the eruption, and there is evidence for global wildfires at the same time. But most of this evidence is open to interpretation, and the jury is still out on whether or not the Toba eruption caused an impact winter. Luckily for us, we may not have to rely on past eruptions to understand what's coming in the future. That's because supervolcanoes tend to leave behind giant lakes of molten rock known as magma chambers. These magma chambers can remain active long after the initial eruption, periodically sending smaller eruptions into the air. When studied carefully, they can teach us a lot about the dynamics of supervolcanoes, including what fuels them, how they grow, and how they erupt. In particular, there is a lot of interest in something called magma replenishment, basically how the magma chamber refills after an eruption. If the magma chamber simply refills with magma from the mantle, then you might expect each eruption to look pretty much like the last. But if there are changes in the magma, either chemically or in terms of volatile content, then you might see changes in the eruption style over time. By studying these changes, we hope to learn more about what really goes on during a supervolcanic eruption, and use that knowledge to better predict what will happen next time. For example, researchers recently analyzed magma from the Yellowstone supervolcano in Wyoming, USA. They found that the magma from the most recent eruption was less dense and had more water in it than the magma from before, which may explain why the most recent eruption was more explosive. Another team of researchers is studying the Taupo supervolcano in New Zealand. They collected samples from Lake Taupo and analyzed the tiny crystals suspended in it. Each crystal contains a mineral called zircon, which forms only when magma reaches a certain temperature. By measuring the chemistry and shape of each crystal, the researchers can reconstruct the conditions under which it formed. This will help them determine if the magma that formed the Taupo caldera was more or less viscous than previous eruptions, which will help them better model future ones. If these studies seem exciting to you, just wait until they bear fruit. One day, in the not-so-distant future, we may be able to accurately predict the size and timing of the next supervolcanic eruption. And maybe, if we're lucky, we can even find a way to stop them. One idea being explored by a group of American and British researchers is to bore a series of tunnels into the magma chamber and pump water into it. The water would solidify into ice, creating enough buoyant force to float the magma away from the weak spot in the crust and reduce the likelihood of a large eruption. Sounds crazy, right? Well, this technology is already being used to great effect at Mount Vesuvius in Italy, where a similar system has lowered the pressure enough that the volcano has not erupted in almost 2,000 years. Who knows? Maybe someday we will be able to prevent all supervolcanoes from erupting, ending the reign of terror of the world's greatest monster. Or maybe we'll just let nature take its course and marvel at the awesome power of the planet we call home. Speaking of things you can do at home, Thanks for watching this SEI show video.